where I am a big dummy and went to share my screen and for some reason subconsciously just clicked the big red stop broadcast button. So we had to switch to another Hangout. My apologies. We will edit the videos together to remove this whole part if you're watching later, and you should hopefully never even see what I'm saying right now. But I'm going to continue on, soldier on, and actually make sure I'm sharing my screen the right way this time, which I believe I am. So let me know if Alexis and Julie, if you can see a big yellow overview.
Yeah, we can see your screen.
Perfect. Okay, so I'm going to walk through some of the use cases, really traditional use cases of can.compute, a little bit how it works, and then at the end, I'm going to probably live code an example with it, just a small example. And also, I'll probably talk about how it works, which I think is really the interesting part. There's actually some really good documentation, inline documentation on how can.compute works. So it's pretty easy to pick up by reading through its source code. So what is can.compute? A can.compute, there's different flavors of computes, which we'll see, but really what can.compute represents is a single value that can change, a reference that will change. It can be the value that the compute houses can be an object, it can be a string, it can be a number, it can be really anything. But when its value changes, it produces events that you can listen to and essentially be notified when a change happens. A compute is, in my opinion, kind of similar to a promise. It's kind of I would say, in some ways, a more complex version of a promise, where a promise promise has a little bit more state, where it has if it's rejected, if it's pending, or a resolved state, which is nice about a promise. But once the promise is either resolved or rejected, it is always got that value, right? Which is good and bad. Right? So if I've got something I'm loading from the server and the value changes, and I get the value from the server, okay, I know about it, and I can put that value on the page, but there's really nothing that promise then gives me if, let's say, the server somehow changed the data later. Well, I can't know that unless I set up some other channel for real-time events or something like that. Can.computes give you a value and then can let you know as that value changes. The drawback of computes compared to promises is that a promise, once it fires off its kind of event handlers, the registered callbacks for a promise, those are discarded, and listening to a promise is always really memory safe. If you listen to a compute for changes, if you no longer care about that compute, you have to make sure you unbind from it. So that's a very high-level explanation, probably too high-level, and I should have waited for the end to actually explain what computes are. But anyways, I think it's useful if you're advanced. You can play that back at the end if you're confused by it. So let's talk about the different types of computes. So the first type of compute are static computes. These are not actually computed computes. These are computes that just have a value, in this case the number 30, and we can read the compute back, and we can also listen to when the compute's value changes. And you can update the computed value by calling a compute. Looks like a function because this actually is returning a function. And when you call a function with no arguments, you get the value of the compute, and when you call it with arguments, it will update the value of the compute. And any change event handlers on that compute will be fired. So computes can also derive their values from from other observable types like can maps and can lists and other computes. So here I've got an age compute, I've got a person who has a name property, and I've got a list of hobbies. And here I can combine all of those observables into a single value. And I do that by passing cancompute a function. And this function, when read, needs to return what the value of this compute should be. So here I've got a compute called info. And if I read it, it's going to give me back essentially, what the return value is here. Now, the cool thing about cancompute is I can listen to in this compute its value changes, but if I change any of the derived values of the compute, the compute's value will change automatically and trigger any event handlers. Now, at this point, when I normally give this presentation with an audience of people who are very familiar with CanJS, they immediately think there's some kind of crazy black magic going on here. Like, how the heck does info know about hobbies? And we'll explore this in depth at the end of this talk, like internals of how cancompute works, but it's actually quite simple. Anytime an observable in CanJS is read, so person.atter, we pass it the name property. Anytime that's read, essentially there's a little signal to any computes that are being evaluated. Hey, listen to when person's name property changes, or listen to when the age computes change event happens, or listen to listen to the hobby's length, because join is internally signaling listen to the hobby's length, so if the length changes, or any of the values in hobbies change, signal any evaluating compute that you should care about these things. And compute just collects them all, binds to them, and waits for any of them to change, and reruns this function to get a new value. The other cool thing here is that computes, once you bind to a compute, I could keep reading info many, many, many times, and it would only give me its cached value. It doesn't actually have to run this function every time I call info once you've bound to it, which is really cool and can really help you with certain performance things, where if you're using the same kind of data a bunch of different places, same kind of derived value multiple places, CanJS doesn't have to recalculate it multiple times. So that's really cool. Okay. So let's see an example. Oh, this is the example I was actually going to build with cancompute. I guess I'll just build it right now. And let's see, do I still have that? JS bin. Okay, so here I have a JS bin. And let's say I have a let's say I have a list of to-dos here. So I'm gonna make a little template. Called main. And I'm going to go through, make a UL, and just go through each to-do, put an LI. And I'm going to two-way bind the for each to-do, it's whether it's completed to this input here. Now, Alexis or Julia, how should I two-way bind this?
Oh, I just lost your screen. Hold on. Okay, so with the new syntax here, you can say Oh, this is a checkbox too. You could say checked, open paren dollar checked, close paren equals. What was the object value?
So you need, well, it'd just be completed, but yeah, you would do checked equals completed. So with can.js, if you want to two-way bind a attribute or property, you need this dollar in here before the property name, and then two-way binding is curly, then parentheses, and then what property in the scope do you want to two-way bind to? Then go kill each in UL. Okay, so here I'm going to create my list of to-dos. Start with that just to make sure I get everything working, and then I'm going to do add to the body a can.view, and I'm loading main, and I'm going to pass it to-dos as to-dos. Yay! Hopefully the two-way binding is working. Really can't tell because...
So is the binding happening, is it just setting the checked attribute of the checkbox to true? Is that what is happening?
It's setting checked to, yeah, whatever the value is here.
Okay.
False, depending on what the value is here. So the cool thing about this is, although there's not many properties besides value and checked that you really can two-way bind to, there are others like selected index and a select that can change or be changed. So this, that was in some ways the problem with can value, is it was just limited to, well, it was mostly doing value, and then there was kind of hacks in place, so it would two-way bind to checked if you were on a checkbox. But now we're really prepared for kind of any element and whatever properties can change on it. So in reality, actually, I think you can two-way bind to a, it's probably possible to two-way bind to a video elements like duration, or not duration, but like time or whatever, where it's current time or whatever. I forgot the name of the property. But things like that you could two-way bind to now.
Is it possible to do like have a filter mechanism with this syntax? Maybe we're getting a little off topic.
We are, but what do you mean by filter?
So if you had like let's say just an input, text input, and you wanted to do display a currency value, but you wanted to keep like a decimal value in as a property.
Well,
so,
you would link to a getter setter, if I think is what your answer. You would two-way bind to a getter setter, I think. Is that what you mean? Like what you would do? Well, what I mean is you want a decimal, you want a input, but you always want a decimal point in there, right? But you want people to be able to enter in like 20, but then it would show up as 20.00 or something.
Well, they would input something like $20.00, but internally we'd always save. We wouldn't show the dollar sign or stuff like that.
So you can do that kind of stuff with getter setters. Internally, you can. Well, it depends on what you might have a second. There's a lot you can kind of change. So you might have to split this up, right? If you had okay, I'll do it. We're totally off topic, but I'll explain it anyways. So so you can listen on change yourself, which is the real event that's driving everything. And then on change, you would do it with $, because you're not listening on the view model, you're listening on the the actual thing. And then on change, you can actually, I believe this works, or it was intended to work. You can, if you want to change some other property or call some method or something like that, you can do like foo, because the value is going to be the, well, check doesn't make, let's say there's an input element like you were talking about. The value might have $1 and you need to remove the $1 from it, right? So you might be binding, okay, we're totally changing this up now. So you might be binding value to like something like pretty value, right? Which is reads value but adds the $1 to it. And people might change it and you need to remove the $1 for what your actual value you want set is, if that makes sense.
Yeah, you would have a second. You're talking about adding a secondary property then, right?
Yeah, is what I would actually two-way bind to a secondary property is exactly what I would do. But you can also, if you didn't have that, you can also do stuff like this where you can call any, if you want to do it as methods, you can also do now element.val. You can do it like that, I think. But you don't need to actually write this .val, but you can do it like that. So you can, on a change, read the current element as a jQuery element, call jQuery's val method on that element, and pass that to some setPrettyVal method. So, or you could just two-way bind to some derived getter setter, and that's kind of what I was trying to suggest at first. So there's a lot of flexibility. You wouldn't do two-way binding up here. You would just read. Do it. And the cool thing is now, let's say pretty value. Here's the really cool thing I love is that pretty value can be a function now. So you can have like helpers or whatever, and you could do like you could actually pass the real value now and say like, oh well, I want $1 in front of it. Right? Does that make sense?
Yeah, that makes sense.
Yeah, we can add things in like that now, so which is pretty cool. Frightening to some, but cool to others. Okay. All right, where was I? All right, we were talking about computes. So I guess what I want to add one more to do in here. And this will be false. Looks like it's working. This will be like mow lawn. And just to show a compute in action, I might want a compute that shows the total number of completed items. So I'm going to pass a function in here. I'll call this complete. And I would do something like, well, depends how sneaky I want to do it, but I could do something kind of somewhat sneaky and just do return this to-dos.atter. I'll do a filter for each to-do. I'm just going to get the ones that are complete. And then I would just return, this returns another to-do can list. So I would read its length. Now this is a way to get all of the completed to-dos in a compute. And I'm going to bind to that compute. So let's kind of see, well, let's see some kind of things in action here. All right, why is that 0? Oh, because I can't spell. All right. Okay, so see here, we got 1. Let me clear the console. Now, I'm going to show when this compute is being evaluated. So I guess I'll put semicolon to get it run. So it's evaluated. Now let me do again. So here you'll notice that it's evaluated twice. Each time we're rerunning this function, but look what happens if I bind a function to it. You can see it's only evaluated once. So you can see here, when it's actually being bound, then it's going to evaluate and start keeping track of its cached version. That way, every time we read complete, we don't actually have to rerun through every single to-do and get the value. So that's really nice from a performance perspective. And now, here, let me put it, this gets called, the change event handler in a compute gets called back with the event and the new value and the old value. So I can console log these. I'll just say was new old val, now new val. And as I change this, you can see it's reevaluated, but we get those change events, which is pretty cool. Julia, Alexis, any thoughts about this?
Do we want to show? I don't know how deep you wanted to get into it today, but I was curious. I think it's a small function where we actually set up the caching, like how this works when you bind on something versus not binding.
Sorry, what do you mean?
Do we want to show any can.compute internals?
Oh yeah, at the end.
Cool. I will reserve my question for a little bit.
Now, I guess here's one interesting thing that like probably some advanced users I think will not get. So computes automatically. Sorry, if you just pass a function to the template, it will get converted to a compute pretty much automatically anyways. What I mean by that is I could add a little bit to the page just saying like completed. And I could, yeah, I'll pass this complete compute. You'll see here now we get it in the page. Because we're putting it, yeah, we got it in the page and we're live binding to its value. But in reality, and this is partially why I said people don't really see computes too much, is because even if you pass just a normal function and stash reads that function and says, oh, this function is listening to, it's reading observables. Well, I'm going to make it into a compute for you anyways. So you don't have to manually force everything into a compute. It'll take care of that. And you can see it just works. Now, what can be tricky, or what people can get wrong sometimes, is it's kind of a hard example to show in a small use case. But they can write their functions and computes so that they're doing more work than they need to. Let me try to give the best example that I can. All right. Let's say, I'm trying to think of a case where this makes sense. So this is the problem with truthy and falsy often. So I'll kind of explain it to Alexis and Julia, and maybe they can help me work through what the real problem is. So sometimes if you're creating a helper that like looks like, let's say I have a helper function and it does something in cancompute. And what it might do is something like, well, if to-dos dot length. Actually, I can probably just do this as my helper function. So if to-dos dot length, I'm going to do one thing. Actually, I'll just create a compute that does this. I'm going to just say something like, I'm going to make another compute function in here called like, you know, helper info. That's just going to say, if all the to-dos are complete, it's going to say like take a break. Otherwise, it's going to say get to work. Now, what people write this as normally is they'll do something like I'll make a helper function. Whether this is a compute or not, it really doesn't matter because everything gets converted to a compute. I'll call this helper info. And what people write is something like this. They'll write something like if to-dos.atter length, then they're going to write return get to work, else return take a nap. I'm going to pass this to my template. And I'm just going to put this at the bottom. Oh, why isn't it working? If to-dos.atter.length.
I mean, you're just checking the length of the.
Yeah, you're not checking the completed.
Oh,
you're not
thanks.
removing
Yeah.
to-dos.
Thanks. Yeah, so I'll just do this. This is fine too. Oh, because this is complete is really returning the length here. Okay, so sure, we'll just do that. So technically, this is just like reading the. It's just getting the length. Now, I can't easily show this, but what's happening here is when I change this, well, this everything that's going on in here and the live binding is rerunning, but it doesn't have to. So like if I put in a console log here. I change this, we see doing something every time I change. But get to work is still showing get to work. So we don't, I mean, if there was a lot of work going, in this case it's totally fine because there's almost nothing happening inside of here. But sometimes, well, what it might be doing is looping through every single to-do and, you know, maybe joining all their names together and or showing all the completed ones or something. Like there might be a lot of work going on in here. And you want to avoid that. So what you really want to do is make a compute that is actually not going to change unless they're all complete or not. Right? So to do that, I could create a compute. Like I might make an all complete. And this might just return what the value of complete is, as long as it's equal to 0. I just realized I kind of got this backwards. right? Really, this is returning, well, this is returning the completed ones, so they're all complete if this is equal to 2, is really equal to to-dos.length. And I can make this if all complete. I'm just kind of switch this around, but it really doesn't matter. I only care when this function is reevaluated. So now, wait a second. Doing something. Helper info. All complete. All complete. All right, this should not be evaluating. Let me see. Okay, now it's not evaluating because it's not changing, but now it's changing. Okay, so that's why. So it is doing the right thing. So you can see here now when all complete, the status of it is still just because I'm just changing marking 1 to complete. It's not everything is complete, so it doesn't need to reevaluate what's going on in here because this is essentially this compute is not changing its value. So this compute never needs to run. Where before, when you're just checking, if I move this code essentially from here to here, well, now it's now listening for when the to-do's length change, but it's more importantly, it's listening to when the completed status of any to-do changes, and it's going to rerun this function. So I'm essentially shifting what this helper info compute cares about from right now. It cares about the to-do's length and every single complete. It cares about everything that's going on in here. I'm changing it instead to only care about the result of this. So unless this compute's result changes, this compute is never going to need to rerun. That's why we don't see any doing somethings right now. Does that make sense?
That makes sense.
Yeah. Julia? That makes sense.
Yeah, I got it.
Okay, cool. All right, so let's keep going on. Okay, so translated values. So another thing can.compute can do, even though it's not used for that very much because, again, you're using the define plugin to do a lot of this now, is you can create computes that kind of work as a getter-setter against some other source value. So let's say I had a glass and it has like a fullness ratio of between 0 and 1, but I want to translate that into a fullness percent. So right now the glass is half full, but I want to make it show it so it shows 50% full. Or is it half empty? Thoughts? Julia, Alexis?
Neither until observed.
Yeah, that's an interesting answer. That's a nerd answer to whether the glass is half empty or half full. I like to think it's half full most of the time. I think I'm a half full person. So this glass is half full, and here we're able to check if the compute function here is called with arguments. Well, that means we're actually trying to set this compute value, but we're not going to actually set its internal value. We're going to set some where it's deriving it's value from, and kind of reverse. We're going to take whatever the percentage is divided by 100 and set that back on glass, because when we're reading this compute, we're going to just multiply full ratio times 100. That's why with this we can call full percent, get 50. We can change it to 75. It'll be 75 because the full ratio has been changed to 0.75. And if you were to change the glass full ratio directly, well, full percent will notice that and still update as well. So I have a demo that shows this in Canvas, but I'm just going to skip that. So there's a bunch of different signatures with can.compute, and they all allow you to do slightly different things. This one isn't really used much anymore. I'll talk about their relative popularity. This is by far the most commonly used one. This is the compute that we've been pretty much talking about this whole time, where you pass it a function and it reads that value as its derived value. Reads that function and calculates its derived value. You can pass it a second argument, which will specify what the this of the function should be. So we've already seen that one. This is kind of the next most common form, even though it's not used very often, but it is used internally to can.js in a few places. Two places that I can think of. It's used internally for can-view bindings when it's setting up like two-way bindings on an element, kind of almost what's shown here. It does that, and it's also set up for reading the scope. For when you're reading a scope for a key value in can-view scope. I'll just show this off real quick in case people are watching. So in here, where is it? Scope. In compute data, this uses that form of compute as well because it needs to, there's a lot of performance optimizations that need to happen. Basically, well, we kind of fast path single key value reads that are in a certain context. So we're able to kind of change how we're doing bindings in different contexts. So if you're doing lots of fancy things, this is how you can kind of create a compute that really is bound anyway to any kind of other value. The arguments are you pass it the compute's initial value, and then you pass an object that takes a get, set, on, and off function. The getter returns what the current value is. The setter will update the derived value. You can see here we're essentially trying to two-way bind to an input's value. And then on passes a function that should be called anytime the derived value changes. So in this case, we're listening to an input. When it changes, we'll make sure we reevaluate. We'll essentially call this get function again anytime this changes. Anytime updated is called, and off is to make sure you tear everything down. This form is the setter form, never really used, not even needed to show now that the define plugin exists. And this is a shorthand form for if you want to create a compute for a certain property on some object, and you want to specify what is the event you need to listen to on this object where this property changes. So here I can kind of easily two-way bind to an input element, create a compute that's two-way bound to an input element by passing the input, I want to listen to the value property. I want to look at the value property, but I want to listen to the change event. And you can do this as a nice shorthand with can maps and stuff like that, really can maps, because you want to listen on the age event for when the age attribute changes on a map. So you could just do this to get a compute for a property. I'm going to kind of skip through this part. Yeah, can maps have a compute function. So if I wanted to get a compute that was two-way bound to the first property of this map, I can just pass this is my map, I call the compute method, pass it to which property, and this will give me a compute that is two-way bound. So I can not only read the compute, I can also set the compute. And yeah, it's two-way bind with that property value. This is totally replaced by the define plugin. Don't want to show it anymore. Use that. And we already saw how computes work in Views. So that's that's I think all I really want to talk about here with that. Any other high-level things about can.compute? Julie or Alexis?
I feel like I had one, and it's slipping my mind.
Okay, no worries. All right, so let's take a little sneak peek at how can.compute works. I'm really just going to do a brief overview of the source code. I did want to not open this up top, so it's easier for people to read. I've already done a full walkthrough of the source code. And maybe Alexis, you can find it while I'm talking. There is a Hangout I did at some point where I went through in depth exactly how can.compute works. And I'm not going to do that within the next 9 minutes right now, but I will give a rough overview so people, wherever in kind of debugging land, needs to kind of see what things are going on, might have at least a rough idea of how to start. So let me open my can.js project. So can.compute is actually split up into a few different parts. High level, oh, and Alexis, if you could find the doco link to can.compute, I think that would be really nice to share before we end. So can.compute, the main can.compute module is actually really small because can.compute, this version of can.compute is really just a shell, a kind of a proxy to the internal prototype-based can.compute. So really what this is doing internally is creating an instance of the can.compute that's based off prototypes and hooking everything up to just essentially call the internal can.compute. It didn't used to work this way, but the internal can.compute makes things a little bit faster, so we kind of made the shell version while still maintaining backwards compatibility. Can.compute, this version is not documented yet, so if you use it at your own risk. We do use it internally a lot of places because it is faster to use it directly, but I would not suggest using it unless you really have a performance problem, and then if you do, talk with us because maybe there's other things that would work better than using this directly. So most of the action of checking the different types of arguments and figuring out what flavor of compute it is happens in this proto-compute. You can see this first initial function is really just going through all the different arguments, checking what they look like, and calling other setup functions based upon what the arguments look like. And for today, the only thing I want to really talk about is how the normal derived types of computes get set up. The setup, getter, setter, when you pass it a function, and the second thing is the context. How does that work? What goes on in there? So we can look at this getter setter function, and really what it's going to do is set up the get and set internal methods to call that function that was passed in, and it's going to call this setup compute handlers, which is really what's there to run this function and set up binding on anything any observables that this function reads. And most of that behavior is hold on. Copy. I don't want it go into my. I don't understand why that's not. What's going on here? I'll just write it manually. I don't know why it's not searching nicely. Setup compute. Well, I know where it is anyway, so I'll just scroll to it. So this setup compute handlers, it's been changed a little bit since I did most of the inline documentation, but what it's really calling out to, so it's getting the compute, it's getting the function, and it's getting the context. And what this is really doing is calling to get value and bind, another file that does a lot of the real complexity to observing stuff. And this has been changed a lot recently since that video to actually make it kind of harder to understand but runs much faster, because this also became prototype based, which improved can.compute's performance quite a bit. So essentially what you do is you create one of these observed info objects, and that takes the function to run, the context to call that function, and an unchanged callback handler. And you call this get value and bind function with an observed info object. And what it does is it's going to set the current observed info object on essentially the observable stack. And then it's going to run its function. And while that function is running, anything like a can map is going to call, anytime you read a can map, you call this can view attr, and if you're reading it, it calls underscore get, and underscore get eventually calls can observe to signal to computes that, hey, you should be observing this map and listening on this event name, which is always matches the attr name. So the proto-compute, let me just open that. Why isn't that not showing? This is not, oh, sorry, get value and bind. So essentially what's happening is you're reading your observables, it calls can observe, and that can observe is going to take what's on that stack that all these observe objects are being added to. It's going to take the top of that, which is hopefully your compute's observed info object, and it's going to add, there's some special cases here, but for the most part what it's going to do is it's going to add that object and event essentially to your observed info object. And then also, if you haven't already bound to it, listen to that object event and call your observed info's callback on changed handler whenever so whenever like person's name changes, we're going to call essentially the observed info on changed handler here. And then once it does that, it also makes sure that because this function is called over and over again generally, it's going to make sure that, hey, if there's anything we used to be listening to that we are no longer listening to, go unbind those things. And then you can see in proto-compute in here, we pass it the function, we pass the context, and what's happening is it's getting passed a function. This is the function that gets called anytime any read observable that's read inside func. Anytime those are changed, this function is getting called, and what it does is, so when the outer compute, the actual compute is bound to the first time, it calls get info and bind, which has the effect of binding on this function. And then every time this function is called, it just keeps calling that same get value and bind, which reruns the function, sees what observables are called, binds on them, and then so that they just keep calling this function again. And the cycle just keeps continuing and continuing and continuing until off the compute is unbound, and then it essentially calls this on get value and bind, this unbind read info, which essentially is tearing down this observable info. The naming needs to be updated here. It's read info here because that's what it used to be called, and then it's observe info in get value and bind, but they're the same kind of thing. So, questions there? I don't know if that made sense.
That's cool. I didn't realize we created an observe info module.
Yeah, well, we didn't really create a module. I mean, we should have it as it needs to get cleaned up again since my last round of performance changes. It was actually much easier to read and understand before I made these, but a little bit of rework would kind of make it easier to grok again, make the inline comments a little bit more meaningful again. I kind of forgot to go back and update them. But yeah, it's really actually quite simple. All it really is make sure everything calls can observe when there's an observable being read, and we essentially add it to this, we essentially bind on it, so it calls whatever compute is listening. We essentially make sure we call something back on that compute so that the compute knows to reevaluate itself whenever any derived observables are being read.
Cool.
So one cool thing that you can do, if you want to see, it's not easy, but it's there. Forgot how to get to it though. I should make this more obvious. I've done it once in the past, and I'm just trying to remember how I did it. There's a way to see, like, given a compute, a bound compute, to see its read info object. It's not easy in Chrome, but there is a way to get to it. I'm trying to remember, because you have to get to this off, and then off is, or on, because then it'll have a read info in its scope. Let me try to remember where this is. So this dot off, you can do this dot off on the prototype, and then you can look in its scope, and you can see the read info object, and you can see what's bound. All right, let's see if we can actually show this to people. So Alexis, is there something I have to do special here to get console access to this window? Debugger or something, probably?
I don't know how to do that, but you can type into that console. Just hit clear. You got a cursor over there.
Huh? Oh, this console? Yeah, but that's not going to do it. I need.
What are you trying to do? Let me ask you that.
I'm trying to show people how they can see what. I'll just do it. I think I know how to do it. I'll do it. Okay, so all complete here. You might want to see what all complete is bound to. So I'm just going to do a debugger here. Okay. And I want to see what all complete is bound to. Here's my compute. Now there's the compute instance, and there's its off, and then I can look in its scope, and I can look at its closure, and I see its read info. And now here is where I can see what it's bound to. I don't know. I probably should make that easier for people to find, but this is a nice debugging. If you're like, hey, what the heck is going on here? This is actually for you guys with your your CanJS IDE or whatever, or your
The
debug
inspector. Yeah.
inspector,
This could look right up that.
this would be helpful because this shows you. So if you look at our example here, and I guess I can't scroll, but I can probably scroll up here. So this compute is. Oh, sorry, we're looking at the all complete, but all complete is really is really going to bind on everything that's going inside this function. So every single to do and its length, and the to do's length is here as well. So if we look at the compute, we're seeing and its completed property. So this kind of shows you the ID of the element, but you can also get to the elements themselves in here. Huh. Surprised. This should say can list. Surprised it doesn't. Interesting. We must be not linking to the development version of CanJS. We should do that in our JS bins. Are we linking to dev? My guess is not.
No.
Yeah,
I never do.
If you do that, then it would show like list here and map. It's a little bit easier to like see what these things are when you have that on, if that makes sense. But anyways, I can see here, this is like the list's 0th property, the list's first property, the list length, and then probably on each item inside the list, it's completed. Interestingly, I do not know what this map 39 length is. Let's see what is map 39. Oh, you know what? I know what that is. Interesting. So that's interesting. So this is like a minor performance consideration, but again, this is just related to what we kind of talked about earlier. So not only is this to do binding on the every single to do and the to dos, like every item inside the to dos array or list, and on every completed item, it's also binding on the resulting list that gets returned here, which is really unnecessary, because if this thing's length changes, well, it's only because something up here has changed. So it's a little bit unnecessary. I mean, all that's happening is there's just a binding being added here and then removed every time like anything changes here. But this is one of those things that can.derive would actually be able to help with, because it wouldn't be recreating this derived list every time. The other way you could help is just, we don't need it to bind here, so you could actually just do .length, and then it wouldn't actually bind on the derived list. But to show this again for people who want to see it, so let's break it down again. So I got my compute. So getting the compute, if it's like in the template, that's a whole nother, can be a little tricky. Might be possible, actually. I might be able to show how to do that. But once you get the compute, you can check its compute instance. Then then you can go to the auth method or the on, and then you can look. It always has the scope of the function, so I can look at its scope, and inside there is going to be the read info object, and that has everything you need. Now this could be something that we actually stick on to computes just to make it a little bit more debug friendly in the future. I could see doing that, especially now that we changed it so the read info instance isn't, before it would actually be creating a new object every single time, like the compute functions were run, and now it's actually just modifying that memory in place. That's why it's a little bit faster now, because it's not having to recreate things. So that's nice. Anyways, let's see if we can actually let's see if we can get crazy and see if we can sniff out, well, it might be a little tricky because I'd want to do it through the inspector, but I can probably get, we could probably do it this way too. So if I have my, oh, I'd have to get the element though. That's the problem.
What are you trying to do?
I was going to try to show, like, so you could see how what name is actually listening to or something like that, or completed here. The problem is that the can view target, or not can view live in this case. It's much harder when it's not surrounded in an element. So hold on, let me see if I can let me see if I can just put this in like a span real quick without it like.
If you just throw a log statement, won't that give you the current context? Won't it be accessible in there?
I'm talking about like after the fact. So like, okay. So I have this span here, right? And let's say I wanted to get that. So let me get that span. This is my only span on the page. Yep. Okay, that's my span. Okay, cool. So this is gonna be a little tricky, and there's better ways of doing this, but it's worth, I guess, with Alexis, because this will give you some ideas on how to make debugging easier for people. So my span has, so jQuery has a special events or a special data hook where it stores all of its event handlers. So I want to see all of the event handlers on here. And this should have a removed event handler, which should have the actual handler that was registered for CanView Live. For CanView Live. There it is. Okay. Okay. So this is a little crazy, but so this is the event handler that CanView Live attaches on every element to listen for if the element is removed. So if it is removed, to tear down any computes to make sure memory safety is working, right? So this is the removed event object that jQuery contains, but this is the actual function we bind, right? And the function we bind, we pass an unbind method, and we probably pass down other methods that are going to have in its scope the actual compute that this CanView Live is listening to and updating every time it changes. So with that, you then go to computed instance and do the same kind of auth function scope, closure, read info, and see that this is binding on pretty much everything. That's because complete isn't a compute itself. It's it's everything in here. So that makes sense. So a lot of these examples would be good to make. If this were a compute, then all complete here wouldn't have to be also listening on all of the same stuff. So by adding can.compute here, this would improve all complete a little bit. Now, if you're using getter setters in the define plugin, well, those things are computes for you anyways, so you don't have to be creating computes all the place but behind the scenes, that's what's happening. But it's worthwhile, I think, to know these things, especially for the audience that's, well, I think this might be a good one to tell everybody at Pitovi to watch, for sure. So, anything else?
I think we're good.
All right, yeah, we went a little long. Where is... Gonna find the Hangout somewhere. That's my tablature for Hush Little Baby. I'm rocking out with the guitar. All right. Well, thank you everybody for watching. And then, do we know what's next week?
Yep. Next week is Can Stash.
Awesome. Well,
for those that are watching, that you've watched all the way to this, thanks for viewing. All the links that we spoke about, if you're just catching us for the first time, those are all in our Gitter chat, which is gitter.im/batovi/js-training. So you can check all that good stuff out. And we'll put some stuff up on the blog too, blog.batovi.com.
Awesome. All right, well, until next week, this is Justin signing off. Thank you, Alexis and Julia, for joining me.